All right, let's have a look at question 2e. This is from the 2019 NCEA 2 Algebra external exam for year 12. And I've had a look at this and I had a bit of a play with it earlier and I was trying to find a good way of actually doing this. And the quick answer is I can't find a quick way of doing this. So I'll show you what I did do. But what I would say is this is actually, in terms of hardness, this is quite a challenging question, and I'm really wondering just how many students would have actually seen this all the way through, so they actually got this correct. Anyway, I'll show you what I did and what I came up with, and hopefully this will make some sort of sense. So, first of all, we've got an equation here, and we're told that it's got two roots, and that one root is n times the other root, where n is greater, not equal to 0. Okay, so let's have a look at this first of all. So we've got, I'll restate the question. So I'm going to put this straight away into two columns here, because I know this is going to take a little bit of working through. So let's go ahead and see how we do this. So first of all, here's my equation, which is x squared plus px plus q is equal to 0. Now the roots of any equation are always going to equal to x is going to be, that is the values, in other words, the actual values of x. If we solved for x, that is the roots, would be minus b plus or minus the square root of b squared minus 4ac all over 2a. So if we then assign values to a, b, and c from the equation, we're going to find that a is equal to the coefficient of x squared, which is a 1. B is going to be p, the coefficient of x to the 1, and c is going to equal the coefficient of x to the 0, which is a q. There it is. So let's now go ahead and populate the quadratic formula with these metrics. So we're going to start off, we're going to have x is equal to minus b, which is a minus p, plus or minus square root of b squared, which is p squared, minus 4 times a, which is 1, times c, which is q, all over 2a. There it is. Or 2 times 1. I just go 2 times 1. Or in fact, just 2 times, just 2. 2 works. Okay. So this is the easy bit. All right. So there is, well, those basically are the roots. So let's now take into account what they're telling us about the roots. One is n times the other. So one root is, and I'll write that, so one root is going to be minus p plus the square root of p squared minus 4 times 1 times q, which is 4q, all over 2. And the other root is going to be minus p minus all of that stuff there, p squared minus 4q, all on 2. Now we're told that they're equal to each other, but one is n times the other. So let's go ahead and write it in that way. So that implies that we've got a negative p plus root, I'll just do it like this, p squared minus 4q is equal to, now this is going to be, let's make it n times, it's an n, looks like an n with a bit on the end there, it's just an n, yeah. It's got an n. Okay, here we go. It's an n times, I'm going to put big square brackets here because there's a bit of stuff going here, minus p minus root p squared minus 4q all over 2. So let's expand all that out and see where we get to. So that implies we've got a negative p plus root p squared minus 4q. Oh, by the way, this is over 2 as well. Let's put over 2. Over 2 is equal to n times all this. Well, let's expand this out. So n times negative p is going to be negative np. And negative n times this is going to be minus n square root of p squared minus 4q. And again, all over 2. Now I'm noticing they're both over 2, so I'm going to multiply both sides by 2. Normally I just put all that in brackets and go times 2, or I'll put times 2 of course, 2 divided by 2, 2 divided by 2, just leaves me with what we had before, which is implies that we've got a minus p plus root p squared minus 4q is equal to negative np minus n all times p squared minus 4q. All right, so that's the first bit we've got. Now, what I'd like to do is I'd like to get rid of a few bits here. So the first thing I'm going to do is I'm going to add this to both sides. I'm going to take this bit here, and I'm going to add that to both sides. So if I add it to this side, I end up with just a negative np. And if I add that to both sides, so one side will cancel out. So in other words, I've got negative n times root p squared minus 4q. And I'm going to put plus n root p squared minus 4q. I'm adding them, yeah? So that and that come to 0, leaving me with a negative np. I'm going to do the same over here. So now I'm going to have my n, I'm going to add it, remember, n, and I've got root p squared minus 4q. And I've still got my minus, though. I've still got my my negative p. So I put my negative p, and I've got my p squared, oh, sorry, p squared minus 4q. So that's all fine. Now I'm going to add p to both sides. I'm going to put plus p. So that now disappears, and I'm left with n root p squared minus 4q. And I've got a plus now, because of the minuses just disappeared. I've got my root p squared minus 4q is equal to, now I've got my p and my minus np, yeah? So that's all looking just fine. Now I'm noticing over here now I've got something common. I've got p squared minus 4q. So these are actually two things in common. So I actually could go ahead and I could factorize this, because what's common to these two? Well, the thing that's common is p squared minus 4q. So I've got p squared minus 4q, and I've got, so I'm going to ask the question, I've got two things. What times p squared minus 4q equals n times p squared minus 4q? And the answer would be n. And what times root p squared minus 4q times, what times that equals that? And the answer is going to be a 1. So I've got my p squared minus 4q times n plus 1 is equal to p minus np. All right, now let's get this bit on its own here. So what I'd like to do is I'd like to divide both sides by n plus 1. I'll divide this by n plus 1. So we're going to end up with p squared minus 4q is equal to p minus np all over n plus 1. And that's going to kind of look okay. Probably better if we factorize that at this point. So I'm going to rewrite it. I've got, oh, that's a root, by the way. Square root of p squared minus 4q. Really want to factorize that. That's going to be a p, and that's 1 minus n over n plus 1. And you could have written it the other way around, 1 plus n, so they looked kind of symmetrical-ish. So we're in the situation here now. We want to get back to, again, this thing here. So this is just a linear, basically, well, it's a quadratic equation, but it's all written without square roots and without denominators and that kind of thing. So we need to get rid of the square root. We need to get rid of the denominator. So the first thing I'm going to do is get rid of the square root. It's probably the easiest thing to do. So I'm going to square this side here, and I'm going to square all of this side here. So squaring all of this, let's see where we get to. So in fact, I'm going to restate this, yeah. Otherwise, I'm going to lose track of where I am. So that's going to equal square root of p squared minus 4q all squared. And that's equal to, and I've got a p 1 minus n over n plus 1. I'm going to square all of that too. So this, without the square root, is just p squared minus 4q. So task 1 solved pretty much. Now p all squared is p squared, and 1 minus n, I'm actually going to write that out, 1 minus n times 1 minus n. And over the bottom, and now I've also got n plus 1 all squared, which is n plus 1, n plus 1. All right, so what have I got here? Oh, that's a 1. Sorry, I've got, it's just 1. I thought it was 1 plus 1 there. All right, so this should be okay. So we've still got our p squared here, minus 4q. And this bit over here, now we've got 1 times 1, so I've got p squared. 1 times 1 is 1. N times n is n squared. And then we've got a minus 1n and another minus 1n, which is going to be minus 2n. That's going to be a plus n squared because the two negatives are positive. And that's all over. And we're going to have this one here. So n times n is n squared. 1 times 1 is 1. And we've got a 1n and another 1n, which is going to be a plus 2n. And that's what we got. Now, the best way around here is let's get rid of the denominator. The only realistic way of doing that is to multiply both sides by the denominator here, which is going to make this a little bit longer. I'll try and squinch everything in as best I can. So this is going to equal a p squared minus 4q times, and I'll put the n squared plus 2n plus 1 is equal to p squared times 1 minus 2n plus n squared. And this is where we can expand everything out nicely, I think. So let's go ahead and try and expand each of these terms by each of these terms. I'll put this in brackets here. Really needs to be. So we've got a p squared times an n squared, yeah? Which is going to be a p squared n squared, or I'm actually going to write n squared first, simply because we're doing it in alphabetical order. What else we got here? We've got, this is so evil, p squared times 2n, which is going to be plus 2np squared. And then we've got a p squared times a 1, which is plus p squared. And then we've got this thing here as well. We've got minus 4q times n, which is minus 4qn. I should have written nq, but it doesn't matter. N squared, that is. Make sure we've got the p squareds all correct here. Yes, we have. Now we've got a negative 4 times this one here. That's going to be negative 8. 8qn squared, qn squared. And we've got a negative 4, it's going to be minus 4q. Okay, and that's all equal to this thing here. So I'm going to go equals, and I've got p, 1 times p squared is p squared. Negative 2 times it's going to be negative 2np squared. So that's correct, and that's correct. And then we've got the final one, which is 1, which is going to be plus p squared n squared. All right. So we really want to, we'll cross out what we can. And then, so if I subtract this, for example, p squared from both sides, that's p squared from both sides gone. What else have we got? N squared p squared is an n squared p squared there and an n squared p squared there. That can go. We can subtract some of these. I've got, what have I got here? I've got the, right, negative 4qn squared. And I've got negative 8qn squared. Or is it q squared? I've got to be careful here. I've got negative 4q times negative 2n. It's going to be negative q n squared, but not q squared. And this one here is, cool, we've got to be careful. Here we go. Negative 4qn squared. Yeah, that's good. And sorry, I'm just having to check this because I've gone ahead and got myself something which I don't think I should have here. Negative 4qn squared. Negative, how did I get negative 8 there? Because I've got my 4qn squared, correct. 4qn times negative 4 times 2 is negative 8. Q times n is not qn squared. So that's no n squared there. My bad. All right, so I think that's looking better. Let's see if we can write this out in one go now. So what have we got? We've got 2np squared. So it's going to be 2np squared. And I've got another is minus 4qn squared minus 8qn minus 4q is equal to negative 2np squared. And I think that's it. So now let's get everything onto the same side. So I'm going to add this to both sides. So that's going to be plus 2np squared. So sorry, I'm moving to plus 2np squared. So now the whole thing equals 0. I think that's going to work out well. So now we've got a 4np squared. That's good. What else have we got now? Minus 4qn squared minus 8qn minus 4q. It's equal to 0. All right. Now, does that kind of compute? 4qn squared. I'm liking that. 4np squared. That is good too. We've got an 8np. And we've got a 4q. And they're all equal to 0. Okay. So I'm wondering if we can add or subtract some things here. So we've got 4np, right. Got one of those. We've got an 8q. I've got minus 4q. Yeah, so that's all good. So what we're wanting to do, remember, we're wanting to get back to this thing here, yeah. I'm noticing that we've got, first of all, everything's divisible by 4. So if I divide this by 4, I'm going to get an np squared. If I've got this here, this is going to be minus qn squared. This one here is going to be minus 4qn. And this is going to be minus, oh wait, divide that by 4 is going to be 2. What am I doing? Sorry. So I've just, there's quite a bit here, and I'm kind of aware that this is, each time I do this, and I've done it a few times just to play around with it, I get different answers. Not different answers, but a different way of doing it. I have to make sure that I'm on track to making sure this is actually going to all play out. Now I'm noticing the actual question has got a positive qn squared, and I've got a negative qn squared. So I'm going to multiply everything by negative 1. So I'm going to get that everything times, including that over there, go times negative 1. So if I do that, I'm going to start off with a qn squared. Yeah. And the reason we want a qn squared is because we've got a qn squared here, yes? And then what we've got here, we've got some powers of n. So we're going to have, this now becomes a minus np squared. So that's now negative. This is now positive. This is now positive as well. So we've got a plus 2nq, or qn. That's going to be plus a q on the end here, all equal to 0. So we can actually now factorize this, and we do need to factorize it because we've got the factors are here. So let's make n outside the bracket. So I've got my qn squared, and put the n outside the bracket. So it's going to be a plus, and I've got my n outside the bracket. So I'm going to say, what times this makes a negative np squared is going to be a negative p squared. There it is. And this bit here, what times n makes 2nq, and the answer is just going to be 2q. And then we're going to say, and we're going to plus q on the end. That's fine. Now, this is looking good, except I've noticed, because that's a plus, they've got this the other way around. So in other words, they've got 2q minus p squared. So I'm going to rewrite it that way. So that implies that we've got qn squared plus, and I'm going to write this the other way around. They've got n at the front. No, we've got n at the back there. They put n over there. So I'm going to do the same thing. I'm going to say this is going to be 2q minus p squared as the coefficient of n plus q. And that equals 0. So that there is what they've got now. So I've had to, really, I mean, this is perfectly correct. It's just the way they want it written. They wanted me to show that that is the case. And that's where we landed there. That is an awful question, by the way. And as I say, I had a couple of shots at it. My problem is I'm old and crusty, and I tend to forget things and don't carry the 2 and subtract the 1, and I end up, so I have to go back over it because my memory is not quite as good as what it was in my frail dotage. So I have to keep going back and just checking that I've got things, lined up correctly. It seems that we've got there, but I've had to go back and to rethink, did I multiply that out correctly? And notice I have to draw my little loops here to make sure I do each one. Otherwise, I often don't. And I didn't do them for this one here, which is why I got to these things here, and I got, did we? Yeah. So I do apologize. Anyway, that's how we get to the answer, and hopefully that makes sense. I bumbled my way through it, but have a shot at it yourself and see how you go. But that nonetheless does get us there. I'm sure there's a better way of doing it. If you know of it, let me know in the comments, because that was just bloody awful. It's just not great. Yeah. As a maths teacher, I just don't know why they would give you a question that involves so much stuff, which makes me believe there must be a much better way of doing it. And I've said clearly there's a major shortcut, which I don't know about. I haven't seen. I'm sure if I played around with it a bit more, I'd get there. But yeah. Let me know if there's a better way of doing it. But yeah, hopefully that makes sense.